I'd like some coherent legal frameworks to be able to operate robots and drones or whatever, because the minute, it doesn't matter how much we aspire to these technologies, if something goes wrong in a workplace with one of them, are the producers, the orchardists going to be adequately protected, and is there a legal framework?
And that's probably the hard one, I guess, for everybody here to think, what am I going to do with all this information and how am I going to use it? So there's probably something you can ask the experts about, how do I, if I suddenly have all this information, how do I easily and quickly make a decision on that? Or, how can I get my people to make these quick decisions? Another thing actually you can think about is, in the last presentation you could see that there is a lot of precision possible in a greenhouse, and I suddenly thought what that actually does is it takes the excuse of the climate and the weather away. So we have, as growers, always have a good excuse of having no control because we haven't got control about the weather. And maybe if we get out of that mindset, maybe other things are possible. Or things, I've seen the berry fruit industry developing from raspberries in the wild, or in the paddock, at about 4 to 7 tons per hectare to now reaching nearly 20. And the only difference was put crop covers over them and again get rid. So I think we have to change and challenge our thinking about what is possible in an orchard or what's possible in vegetables without even going into the high-tech greenhouses.
Before we start doing, I think it's the dry fruit industry, redesigning our trees, what can we adopt now and how far off is it?
It's a good question. We've changed trees from having huge big apples growing seedlings to dwarfing rootstocks. That was also to actually be more precise and to reduce labour costs. And I think we're still on the same thing, to reduce labour costs and have more control. But please, what can we use now?
Whilst we're using what I call a low-level technology of NDVI imaging, that will tell us plant health, crop health, vigour, and that can be scanned right now. As David alluded, satellites have been giving us that for some time. But what the advantage of the UAV does, I know in the rice industry, that they need very timely information. So I want an image next Thursday, not next Friday, but next Thursday. Next Thursday it's overcast and cloudy to get the satellite. The UAV flies under that and gives you that imagery within 2 or 3 hours. So that technology is there today. It's an aerial imaging platform. The sensors that we have, obviously from a research perspective, are not nearly of the high quality, but in terms of practicality, do I spray today? Exactly where do I spray? Do I have a problem in this area? I can ground proof that problem, find out, are those trees being affected by bugs, irrigation, nitrogen? What is the problem? That technology is available to you right now.
Yes, and that's what this is also about, is to actually give feedback to the research people, because quite often in research, unfortunately, there is not enough guidance from the industry of what is actually needed. And anybody can actually, that's why I asked about what you wish for, because you have to tell the research people what you wish for, what is the most important now and what is the most important in the future.
And it's just not the yield, but it's the growth size, and to be able to predict your model on what your average fruit size is going to be, and really predict what counts for the marketing, what counts are we going to have. We don't have to pick them, then sort of sort them or pre-sort them or to find out then. We should know pretty accurately what we're getting there as well.
And
but
is that
with the only thing, be really good to be able to do it from a satellite in some ways, because there's a lot of lazy sort of orchards out there that won't bother doing it. So we're going to get a true picture of the whole crop in Australia, because I don't care whether it's just apples and pears or cherries or whatever. Across the board, it's pretty.
It's very important.
Under the first round of Barnaby's R&D for profit funding, the first tranche that he put out, the 60-odd million, Horticulture Innovation Australia received 3.8 million to co-fund a total of $7 million into a single project which has three components in it. One is the use of sort of satellites to assist with disease, pest and disease management. This is for tree crops in Australia, to be able to support the need of regions for inventories at orchard, region and national scale, using the satellite sort of data that's now freely available and regularly updated every week. There is a on-ground robotics component that James Group is running, precisely around flowering and fruit sensing on the ground, and because this is a HIA-driven project, it must have industry outcomes at the end of it. It simply must. It's not just another R&D project. So the component of that in the guidelines is around providing advice to industry, if even a prototype sort of system that could help with things like fruit load prediction, average fruit size, flowering. And there's a third component, which is in-shed and in-situ quality assessment. In other words, sorting and grading using some of the new optical sort of techniques that are now available. So that project kicks off 1 July. It's a 4-year project. And I note that it is primarily focused in Queensland. It's been heavily invested in by Queensland Government and QDAF. So there is an opportunity here for the state of Victoria, through your network and the fact that you are HIA levy payers, to sort of be slapping the table and say, we want to be involved in this directly, some trials maybe. They may need to be co-resourced, additional resourcing may need to be required from Vic Government and HIA, but at the end of the day, there is a massive project that's about to kick off that there is no reason I see why you guys shouldn't be involved. So just bear that in mind and maybe talk to your HIA people. There's the first meeting kicks off tomorrow, James will be at. I'll be in the Corolla doing it on the phone. So
Yes, David?
We'll never be short of food in the world. Never. And you see that lettuce thing feeding out. And I think at the moment we're being given a whole heap of spin by our governments about us being the food bowl of Asia and all the rest, because they're going to get onto this stuff faster than we can produce it and ship it. And so I think the implications for us as fruit growers and horticultural growers, or any farmer in Australia, is that we're going to have to make do dominantly with what we do here really well, and that every time one of those is adopted, you've got to chase it, otherwise you're out of business. You can't stay where you are, you've just got to... I've been at it for a long time. I've always been too late adopting new technology. I've always been chasing the tail. You just got to go there.
Yes?
Seems that a lot of this technology you've got is in the broadacre and the vineyard and the orchards. What about for our sector, the intensified vegetable industry? One, is there any money in that HIA project looking at any aspects in the vegetable industry? And secondly, the technology, could it spread to the fact that, say, like, we're having an agronomist on the ground 3 days a week and we do a lot of spinach, collating weather data in correlation with the feedback, the radiation, what is it, the ultraviolet rays?
Yep.
Mildew is a huge problem within a spinach crop. By the time the agronomist detects it, you've got the problem. Yep. Is there technology in place maybe that you could collate the information and maybe get it just at the onset or beforehand?
If you have the right gizmos, you can actually measure it. So you could tell your agronomist that he has to get into that kind of technology and understand it, so he keeps tabs on that. Graeme?
What you do today, you might see the results in 7 weeks or whatever. You really need a pre-flowering stage. You know, what's your vegetative balance of the plant? You know, are you going to get good flowers, fruit set, flower initiation, all that? You need that before it flowers, because once it flowers, that's it, you're set. Yes, you've got to maintain it, I understand, but looking at the crop, and we do regularly, before that happens is important.
Yes.
So you really need to get in earlier than just the flowering.
Just before flowering.
As I see, that's part of the equation. The concept of NDVI or cover is really giving you potential yield of a crop.
Yeah.
Then the idea that you can come along and measure flower number and then fruit set and then after thinning, all those components are feeding into that, we call it a yield gap between the potential and the actual. And of course then the actual becomes part of your forecast.
Yeah.
So it'll be integrated into it.
If I could add to that, we've done walnut plantation and they're asked when. I said, when there's sufficient leaf matter on the trees, let's do the imaging then. And at that point, we were able to pick out specific trees that had problems, and they showed up very early on in the piece.
In grapevines, it's about the previous season image of cover, or NDVI, can predict your following season's crop based on, you know, initiation in that previous season, even though, you know, we'd have to do a bit of work on that to test it in horticultural crops, but, you know, that'd be another component to that too.
I think the biggest thing with most of this stuff, the technology's all sort of proven, but every time you adopt a new piece of research or innovation, you have to change your management system, and it's a lot.
And somebody once said to me, if you wait for the future, it's going to be very short. So I think you can't wait until all this research is finished, because it's never going to be finished. So you might as well start your future now to have a bit more of it.
No matter how conscientious the growers are, enthusiastic they are, you will get varying quality of data coming back. So what can you use, what other information can you divine from what they send you that will give you a hint as to their reliability? So for example, whenever our growers now do measurements for us and send the data in remotely, we get them all to take a photo of what they've just done. Right? For example, it could be the way they took PDL samples, or the way they shaved a quadrant of pasture, or what the tree looked like that they were about to take a particular sample from. And if it's an invasive process, we actually get them to do a photo after the event too, in case you can get a check of, you know, just what the impact was on the target if they're measuring something that's small. So what we're finding is when we go through the data and we see it all spread, we actually literally click on the dots and we see the photos and say, oh, now we know that particular grower did something a bit funny here, or they've got the wrong part of the tree, or they've not pulled their soil core correctly. And so straight away we can attribute a weighting, a reliability index to it. So step one is, if you're getting growers to collect data for you, get them to take a photo, and you can buy them all a cheap digital camera, rig it up so that it's colour balanced, so you can absolutely benchmark one against the other, and it gets stored up there with the other data they upload. So that was the first thing. The second one though is simply, was very encouraging, was how excited and willing the growers are to do it, because our growers are our most valuable learning resource. And as I quickly earlier, there's no way that we're the smartest cookies in the room up here, no way at all. What we can be good at is capturing that intrinsic knowledge and experience and wedding it into our learning.
You taught the grower to know how to do it?
So we whip around, train them.
Then you don't have to go and teach it. It's
No,
already happening.
no, we trained it. We even film a little YouTube clip to remind them this is how you do it. And then we have that benchmark information, ancillary information, photos just coming back. It's nothing to snap an iPhone photo, and when you hit the send on the data, it carries a photo with it, with the GPS coordinates if you wanted to, if the grower wants you to know where they were and what they were doing. So crowdsourcing is a completely untapped resource in the way we learn as researchers, and like I said earlier, we're actually reinventing some of our fundamental agronomy, because we actually didn't appreciate, oh hang on, there's a better way of doing this, and we learn it from the growers, and then we're going back and re-investigating things. So it's a wonderful future, it really is.
To actually use some of the younger generation, for them all this technology is just there, you know, they've grown up with it, they don't even know what a fax machine is. So, you know, we should utilise the kids, the schools, whatever we can in new technology, and actually getting data and submitting data. That's probably you know, quite a helpful way of getting started if we're a bit afraid of it.
Black spot and codling moth are the two biggest pests, I suppose, that we face in apple growing, and the black spot predictor basically tells you when you've got a spray, and it's also now got an overlay that you put in what the spray was, and you find out what the coverage period was by the amount of rainfall and all the rest. So it's a software program that's predicting when the release is occurring, the primary release. It also is predicting secondary releases the whole time, and allows you to tailor your spray applications prior to the event. Most times is what happens, and then if you do miss, you've got the chance to use one of the kickbacks, not the curatives as it's called, but a kickback to control it. So every time you actually know whether you've caught the caught the disease at the right time or not, and then you've got a management tool, because if you've missed it and you have got a window, then you're locked into another period set of spray programs, basically, then you've got to concentrate on the secondary infection.
But it's fantastic to actually be able to use technology from overseas, and sometimes it has to be adjusted, but there is a lot out there. But
everything really revolves around temperature.
And
plant production systems are all temperature, so it just, I think sometimes we try to reinvent the wheel. But what I do want to say is it helped me actually understand how that disease worked. Before that, there was quite complex things, mills tables and all sorts of things, and you were playing smoke and mirrors, but this actually helps me understand how both those pests work.
We have now data, not for apple, not for fruit, not for vegetables, on actually what the issues are or what the issues have been, and make good decisions on what research we should do, which disease or pest was really bad. We really don't know. I mean, we have opinions about it, but we have no data. And if we could do even better on having that kind of data, and then, you know, if we get into more precision production, to actually share the data, not saying this is mine, but saying, you know, where the issues are, to actually now to direct research, because we all kind of, by being so secretive about our data, we also don't get enough help in getting better information. I mean, one thing would be even good to actually have a proper mapping and tracing of fruit fly, and I don't think we have that. No. We really, in a lot of areas, when you look at plant health, we're flying blind. We really have no idea, and relying on somebody stumbling across a new disease. And by the time you do that, it's quite bad. Like in Tasmania, we've got a new downy mildew affecting poppies, and suddenly it's affecting 30,000 hectares. I'm sure somewhere something was asleep, because it can't be just suddenly in every paddock. So something has happened, and we've all missed it. And we've got 2 agronomists per square kilometre, so we have all missed it. And if we had systems like surveillance systems, a system that actually alert us of what's going on regionally, we probably maybe wouldn't have missed it. The same biosecurity, cucumber virus, banana. I mean, nearly every day something is happening, and maybe we're missing a lot. So that's the thing, the power, apart from on the farm level, the power this kind of technology has for the industries.